In classical logic, there is a law that states that every proposition must either be true or it must be false. We call it the Law of Excluded Middle. In type theory, this would mean that every proposition is either provably true or provably false. However, there are some propositions in mathematics that are neither provably true nor provably false. We must therefore conclude that in type theory, the law of excluded middle does not hold. That being said, we can prove that the law of excluded middle is not true. Let's see how this is done. Bear in mind, this is going to be a mind twister, so feel free to pause or rewind. Recall that we define a proposition to be not true when we can construct a function from the proposition to the empty type. Therefore, to construct a term of this type, we need to construct a function that takes in another function f that maps a plus not a to the empty type and returns a term of the empty type. Alright then, suppose we were given the function f. How would we construct a term of the empty type? Well, if only we had a term in the type a, we could apply the left injection to that term and then apply f to that term to get a term in the empty type. But we don't have a term in A. But what about a term in not A? To construct a term in not A, we need to construct a function from A to the empty type. But that is exactly what we have just defined. Here's how we write this. We make use of something called lambda calculus. We write lambda y, where everything after the lambda refers to an input. Then we write a dot, where everything after the dot refers to the output. And then we write the construction of a term in the empty type. F applied to the left injection of y. Now that we have a term in not A, we can apply the right injection to it to get a term in A plus not A. Finally, we can apply f to this term in A plus not A to get a term in the empty type. Putting this all together, we can construct a function that takes in a function from A plus not A to the empty type and returns a term in the empty type. We then define g to be equal to this term, and we fold our definitions on the right hand side up again to get g is a term in not A plus not A. In other words, we have just proven that it is impossible for any proposition to be neither true nor false. Thanks for watching.